One of the things of the Convair 580 as an air tanker is we changed the upper panel here. The middle we've reserved for avionics, and that follows down to the bottom. The two panels that are normally similar is this one, which is the aviation, the de-ice panel for the pneumatic side of it, and this is the de-ice panel for the electric side of the panel of the de-ice system. We have the AC and DC control panels here, which would normally have been very close together in a regular aircraft. Up above we have the lights, and over here for further lighting panel, which of course the first officer looks after. This panel on top is standard for pretty well every Convair and is the starting panel. This ADF installation was always a bugbear, and probably still is. The ADF knob tends to implant itself in one's forehead the first time you get into the airplane, and you soon learn that you always duck this knob in order to get to your seat. It doesn't matter whether you're in the left or the right seat. It's something that gets embedded in your forehead. The bottom panel, or normal panel here for the Convair, does again change from not from airplane to airplane in the air tanker type, but it does change from a normal Convair. We have here the emergency dump button, which can be accessed from either pilot in the event of an emergency and we need to dump the load. Going further down here now, we have the emergency panel, which consists of the left and right hand emergency handles. And as we go down, we now look at the two power levers on either side. It always brings to mind to me that the first thing that we're trained in ground school is the simplicity that was built into this airplane, which was push to go, pull to whoa, if in doubt, pull it out. And the emergency handles have 11 functions that they perform when that handle is pulled. Going further down now to the bomb panel is here, and then we go through to the nav section of avionics section down below. What we're looking at here is the heart of the bomb system for a continuous flow tank. It consists of specifically this panel here with our quantities of all half, 1/3, 1/4, and 1/6. The other numbers indicate the number of gallons per 100 square feet that will be distributed by the continuous flow tank. So as it's sitting here, all at 0.5 would mean half a gallon per 100 square feet, which might be seldom used because it would be very, very light grass that might be used in, and could put in perhaps almost a mile of line. To be effective though, usually if this drop was used, it would be at a coverage level of 4 or better. At half, a lot of times we will use half at 6 or max. A third, the max is a 4. The 1/4, the max would be a coverage level 4. And a sixth will either go the max that the tank can give us, given what the computer has in it, and again, max 1 or 2. So the sixth load is not usually used, but is available. One of the interesting non-technical innovations that Convair came up with is a jump seat, and it was located here in this avionics panel. On the starboard wall, you'll see this box protruding. This is the brains of the system. This is where the computer is that does all the work to control the spread of the retardant from the tank. The retardant tank is located right on the center of gravity for the aircraft. It's supported by 2 beams inside here, which transport the weight of the tank through to these formers that are part of the fuselage. This ensures that the weight of the tank, in addition to attach points fore and aft, is distributed throughout the airframe of the aircraft, as opposed to simply being the tank hanging on the spars, as most people think. Having completed the interior inspection of the airplane, it's now time for the external inspection that would normally be done before the airplane is considered ready for a first flight. From the ladder then, we move to the tank, checking to see things such as the vent for the tank itself is open. We check the tank system accumulators to make sure that the pressures are as they should be for the accumulator system. We then go to ensure that the press to test for the lamps is working, which cannot be done obviously unless the master switch is on. Check the battery is firmly in place. Also that the overfill for the water methanol system is clear, ready to go. There would normally be ground power, could be plugged in right here on this panel. From there, we check the caps are on. And for your information, this tank on this airplane is smaller than the one on the Lockheed Electra, but the same continuous flow tank. It'll hold about 1,750 imperial gallons, 2,100 US gallons of retardant, or about 8,000 liters. From there we go and check the brakes and the wheels. Okay, here we are in the port or left-hand nacelle underneath where the wheel well is. We normally will check this for any signs obvious of any leaks for hydraulic fluids. We also check that the carbon dioxide bottles that are used, 2 small bottles to open the valves for the starting mechanism, are checked and they're up to pressure. We also check to make sure that this mechanism here that closes the gear doors is not only level, but that both springs have got the same tension on them. From here I would move forward, again looking at the gear jack to make sure that it's not leaking anywhere that's obvious. And of course we would be removing the gear pin so that so that we don't take off and select the gear up and the gear don't come up because the pins are in. Believe me, that has happened before and will probably happen again. From here we now will check the brakes. For the wheels, we're looking generally at the condition of the rubber and the brakes themselves to see that the 3 pucks are firmly in place, and one can also tell just how close these brakes are and how well they're set by the amount of puck that we can actually see, and these brakes look quite good. As we continue our walk around on the Convair 580, one of the important points is this valve at the aft of the tank. It's set with 2 springs that allow 8 pounds pressure on top of the load, and as the airspeed increases, of course, that valve will open or close in order to give a constant pressure on top of the tank. From the tank, we ensure that these doors here are closed and latched. We have the same overfill dump here and at the front where the Electra has on its tank. As we go by the engine, one of our important things is to look in this exhaust. The pipe on the outside is actually part of the fuselage, whereas on the inside is where the proper exhaust sits. So it's important when you're doing a walk around to look to see that the actual exhaust pipe is equidistant from what you're actually seeing from the outside. From here, we check that the fuel cap is on and properly set. For underwing fueling is where that is. And then we'll ease our way out and check the fuel vents and that the 3 static wicks are on the aileron. And static wicks, while they seem to be rather innocuous, are actually a requirement for the airplane. The airplane normally has 12 wicks, 3 on each wing, 2 on the elevators, on each set of elevators, and 1 on the rudder, or 2 on the rudder. If there's 2 missing, the minimum that we can actually dispatch with is 10 static wicks. Seems like a small point, but that's nonetheless part of the airworthiness. As we continue the walk around, over here we would be checking the landing light to ensure that it looks serviceable. We come through to the ground gas turbine generator, or GTC as it's known. This engine is like a small helicopter engine, about 225 to 250 horsepower, but it is there specifically to provide the bleed air that will start this engine. It can be shuttled, of course, and bled across to the other engine as a first start, but normally this is the engine that's first started because it's the closest to the GTC. We then come and ensure that both latches are properly closed, all of the screws are properly in place, the 2 plugs are removed, and that's from the oil cooler here and the air intake. The propeller blades, we check whichever blades are handy, just again for general look and use, because if we can't turn the prop blade, more because there's a brake that holds it in place. From there, the similar thing happens down this side of the cowling for checking for screws. Coming around to the front, the static ports, of which there are 3 this side and 3 on the other side, also need to be checked, because if this airplane was on base, there would be plugs in the ports to stop the production of bees and wasps, mud wasps specifically, that go like little holes like this in the pitot tube and build nests in there. Doors locked. AC power, if we had it, and we seldom ever do, would be this panel here. The other portion here is the pitot tube, which of course we would remove the plug from, and you're looking here at the vane for the angle of attack indicator in the airplane. Very important that vane is free and clear, because of course that tells us when we're anywhere near a stall. From there, of course, we would go in to check that the nose gear and the mechanisms for the nose gear all look solid, and that the oleo is about 4 to 4.5 inches of extension. Here we are at the tank of the Lockheed Electra. This tank holds 2,748 imperial gallons, roughly 3,300 US gallons, and 12,500 liters. The vent to put air on top of the tank is called a NACA vent in the front, and that brings air on top of the tank. The tank exists only to this high on the side of the airplane. Those vents bring air in to allow air on top of the load when it drops. There are 2 overfill dumps, which are here and to the aft, which I'll show you as we get there. Those overfill dumps are there in the case of an overfill by the loaders when this airplane is being loaded. It's loaded through this 4-inch cam lock connector, and fire foam can be added to the load through this small 2-inch connector. As we go toward the back of the tank, you can see the vents are open on top so that it doesn't pressurize too hard the top of the tank. And right aft you can see the doors partially open.